You know the feeling, right? You ask an AI a question, and you get back this answer that sounds so confident, so plausible, and is just completely wrong. It feels like the whole system has a leak in it somewhere. But what if that leak isn't just a bug? What if it's a fundamental flaw in how today's AI is built? And what if the answer isn't to just keep patching the holes, but to build an entirely new kind of container, a Glassbox?
So here's how we're going to break this down. First, we'll get into what we're calling AI's leaky bucket problem. Then, we'll look at the crazy complex patches everyone is building to try and stop the leaks. After that, we'll explore a massive paradigm shift, moving from guessing to actually knowing. We'll peek inside the Glassbox tech that makes this possible. And finally, we'll talk about what a future built on comprehensible AI could really look like. All right, let's start with that feeling of unpredictability. We have these incredibly powerful AI tools, but there's always that little seed of doubt in the back of our minds, isn't there? We just can't fully trust them. And it turns out there's a really good reason for that. I mean, we've all seen it. AI models just hallucinating facts out of thin air, making up sources, or confidently saying one thing and then the complete opposite a second later. We know they're not perfect, but why? Why does this happen at such a deep, fundamental level? What's actually going on under the hood that makes even the most sophisticated systems so unreliable?
You know, SEO expert Mark Williams-Cook absolutely hit the nail on the head here. He calls it the leaky bucket problem. The core issue is that these systems are non-deterministic, and that's just a fancy way of saying you can ask the same question twice and get two totally different answers. Now, on a small scale, that's kind of a funny quirk. But as Mark points out, when you're scaling this to trillions of queries, those spicy and wild answers, they stop being funny errors. They become massive systemic problems.
And this slide right here visualizes the whole chain of uncertainty perfectly. See, it's not just one single flaw, it's a cascade. It starts with a sampled data corpus, which gets compressed into patterns during training. Then, for inference, we add even more layers, like retrieval augmented generation, or RAG, which itself is just another best guess process. Every single step is an approximation, a guess layered on top of another guess, and that is what leads directly to hallucinations, opacity, and this brittleness we all experience. The system is literally designed to guess, not to know.
So when you're faced with a fundamentally leaky bucket, what's the first thing you do? Well, you try to patch it, right? And that's exactly what the industry has been doing, inventing some very clever and sophisticated patches to try and give these models a kind of long-term memory, to make their guesses a little more educated.
To try and solve this memory problem, we've come up with some brilliant but unbelievably complex systems. The two big ones you hear about are RAG and knowledge graphs. Both of them try to give the AI some external factual context before it generates an answer. But here's the thing, at their core, they're just elaborate workarounds. They're trying to bolt a memory system onto an AI that was never designed to have one in the first place.
And this lays out the trade-offs perfectly. On the one hand, you have RAG, using vector search. It's super popular because it's pretty simple to get started. You just chunk up your documents and embed them, but that simple act of chunking often breaks the original context. And as your data grows, you get memory bloat, conflicting facts, and pretty soon the real signal gets totally lost in the noise. On the other hand, you have knowledge graphs. They're more structured, which is awesome for reasoning, but they are a nightmare to build and maintain. Super complex, super expensive, and they can get incredibly slow. And the complexity just keeps spiraling. We're now at a point where we have techniques like auto-schema KG, where we are literally using one AI to automatically build these complicated knowledge graphs just to feed another AI. These things use incredibly advanced tech, like FAS for lightning-fast searches in massive datasets, and HNSW indexes, which are basically like a super smart GPS for navigating all that vector data. We're building AI to manage the AI, just layering complexity on top of complexity.
But here's the crucial point, the bottom line. No matter how sophisticated the patch, whether it's a fancy RAG pipeline or some auto-generated knowledge graph, we haven't actually fixed the leak. We're just getting better at catching the spillage. The system is still fundamentally probabilistic. It's still guessing, just with a little more context to help it out. So, what if we stopped? What if instead of trying to patch a leaky bucket, we could build a perfectly sealed, totally transparent one right from the get-go? A system that's designed not for guessing, but for knowing. And this image, this says it all. For years, all of AI has been about building better shovels, tools that just help us dig through these massive piles of unstructured data faster and faster. But this new approach, the Semiotic Web, it's not about digging at all. It's about creating a precise treasure map that shows us exactly where the value is, letting us go directly to it with absolute certainty.
And that is the absolute key difference. The Semiotic Web is a deterministic system.
It's not based on fuzzy pattern matching or statistical probabilities. It's engineered, from its very foundations, for genuine comprehension, with trust and traceability built into its DNA. It's a move from a world of approximation to a world of certainty.
So what does this Glassbox actually look like under the hood? How in the world do you build an AI that doesn't guess? Well, it all starts by changing the most fundamental building block of information itself.
It all begins with this thing called a tokum. Now, this is not like a traditional AI token, which is really just a piece of a word. A tokum is a token of universal meaning. Think of it like a unique, verifiable, almost cryptographic fingerprint for every single concept and the relationship between concepts. It's basically the semantic DNA for this new web. Now, this process, called tokumization, this is where the magic happens. A component called the Tokumizer takes in data, you see it here as an RDF triple, which is just a simple way to state a fact, like Paris is the capital of France, and it converts it into these unchangeable tokens. And here's the breakthrough. This one single operation creates two things at the exact same time: a rich, interconnected knowledge hypergraph and a mathematically perfect, sparse matrix called an HCNV. There's no separate error-prone step. It happens all at once.
I absolutely love this analogy because it's perfect. Today's AI is a black box. It tastes the cake and makes a really plausible guess about the recipe. Semiotic comprehension, on the other hand, gives you the cake, the exact, auditable recipe, and a complete history of every single ingredient, all the way back to the farm. It's the difference between a plausible guess and a provable fact.
And here's the math that backs it all up. Classic AI runs on the formula y is approximately equal to dx. The output is an approximation. The explanation it gives you is plausible, but it's never guaranteed. The semiotic web runs on y equals dm. It's a perfect, canonical construction. Every single element is auditable and backed by pure logic. That, right there, is the difference between a black box and a glass box. It's provable, it's certain, and it's completely trustworthy.
The architecture that makes this possible is called HCNV Colbert. And folks, this is a profound shift. In a classic AI model, the dimensions in a vector are just anonymous numbers in a big matrix. Their meaning is fuzzy. But in HCNV Colbert, every single dimension is explicitly named by a tokum. So there is a single, verifiable, permanent address for every concept. All of the ambiguity is literally engineered out of the system from the start.
So let's put it all together. This new Tokum HCNV architecture fixes all the leaks. The weak bolted-on knowledge that causes hallucinations, it's replaced by an integrated hypergraph of grounded truth. The weak provenance that lets AI just make up its sources, replaced by cryptographic hashing that lets you trace any fact right back to its origin. And most importantly, the probabilistic multi-step guessing game that defines the leaky bucket, that's replaced by a deterministic grounded answer that you get in one single efficient operation. That's the Glassbox. Look, this isn't just a cool technical achievement. This fundamental shift from a black box to a glass box has absolutely staggering implications for how we find and interact with information every single day.
The results are, well, they're almost hard to believe. In head-to-head tests on really complex queries, this new system is up to 20,000 times faster than traditional search. A query that used to take 150 milliseconds is done in just 10. That's not just an improvement. That's a total redefinition of what real-time even means.
And this brings us to the grand vision here. An entire digital world built on a completely new foundation. A semiotic web where information isn't just stored and retrieved, but is genuinely understood. A world where every bit of knowledge is traceable, every answer is trustworthy, and the systems we rely on are, finally, completely comprehensible by design. We're moving from a world of building better, faster shovels to dig through these endless haystacks of data to a world where we're finally being handed a map that shows us exactly where every single needle is. That changes everything. It's a shift from just retrieving information to truly comprehending knowledge. And it leaves us with one incredibly exciting question to think about. What will we discover when we can finally read the map?